let's just start really quickly, go through these first 6 problems, deciding if they are polynomials. This guy here has x squared has a constant of 8, and so it's a polynomial. It's a pretty clear polynomial. They want us to now write it in standard form. That just means write the highest power first. That's negative x squared plus 8. They want to say, what's the degree? It's degree 2, because the highest coefficient, or the highest power is 2. So degree is 2. What type is that? Okay, the type of polynomial has to do with its degree. It has everything to do with its degree. If it's degree 2, we call it a quadratic. Okay. And then lastly, they want us to state what the leading coefficient is. And the leading coefficient is very closely related to the degree. Wherever you go to find the degree, you look in front of that variable there to find the leading coefficient. So the coefficient of x squared is the one that tells us the degree. The leading coefficient, or the coefficient of that is -1, so the leading coefficient is -1. And it makes a lot of sense when you write it in order of the greatest power to the smallest power. This is the one in the lead. This is the one out in front, so the leading coefficient is the one that's in front of that term. Okay, so number 4 is a polynomial. We got x to the 4th, we got x to the 1st, we got a constant here, we have real coefficients, so all of this makes a polynomial. Alright, and we'll write it in standard form. Writing the highest power first, so that's x to the 4th, then 6x, that's the next highest power for x, minus 3. What's the degree? Well, we already have kind of determined that by writing it in standard form. The one we put out in front that had the biggest power, that makes the degree, it's degree 4. That's called a quartic, which is kind of funny that this one that's degree 2 and this one's that's degree 4 both have names, they're types. The prefix of them both has to do with the number 4, quad and quart, both having to do with 4. I'm not sure why, I've just always thought it was interesting. Okay, so I actually just looked that up spontaneously, and the reason for it is that in Latin quad means more like square, and not so much 4. We use it for 4 a lot. Not these days, but specifically it means square. So this is a x squared, so it's the one that has a square. And then let's see if we had one, which we will here, so we'll talk about that in a second. But there you go, that's quadratic because it's square. Quartic, that actually means 4, and this is a degree 4, so there you go. And what's the leading coefficient of this one? Well, we have written x to the 4th out in front, and the coefficient of that is 8, so the leading coefficient is 8. Next, we have x to the 4th, we have a constant. The constant is a real number. That's all that matters. Even though it's kind of a weird real number, it's a real number. It's just the square root of 6. There's some number out there, this infinite decimal that goes on forever, that if you multiply it by itself, it gets you 6. So it's just a real number. So is pi. Pi is a real number. It's the coefficient of x to the 4th. So, yeah, that is a polynomial. And to write it in standard form, it's already done. X to the 4th is the highest power of x, and next is the constant, and that's it. So it is written in standard form from greatest power to least. So it's a degree, what? Degree 4. What kind is that? That's a quartic. And what's the leading coefficient? It's the coefficient of the highest power of x, and that is pi. Weird, but true. Next, we have x to the 3rd. We have a constant. We have real coefficient here. Real coefficient. Square root of 10 is a real number. Times x to the 3rd, that's fine. You got 5 here, that's a real coefficient. The thing, though, is this exponent right here. This is a negative exponent. They need to be positive exponents. So this one is no good. This is not a polynomial. Gotta have powers that are positive. So let's move on to 7. We've got x to the third, x to the first. We have a constant. We have real coefficients. This is, even though this is negative 5/2, it's a fraction and it's maybe inconvenient, but it's still a real number. So we have real coefficients in front of powers of x. So it is a polynomial. So for number 7, we'll write it in standard form. It's actually done. We have the highest power here, the next highest power next, and then it goes in order all the way through. So now the degree is 3. The type now is called cubic, because this highest power is to the third, and that's called cubing. Okay. And lastly, what's the leading coefficient? The coefficient in front of the highest power of x is negative 5/2. Right there. Number 8. Is 8 a polynomial? We have x to the third with a real coefficient of 8. We have x squared with a real coefficient of negative 4. But now what we have is 2 divided by x. It needs to be 2. If it were 2 times x, that would be a polynomial, but it's 2 divided by x. So you can't have x in the denominator and call it a polynomial. It isn't not. So, no. All right. Next, we'll do number 9. F of x equals 5x to the third minus 2x squared plus 10x minus 15. And they want, by saying x equals 1, what they're saying is they want us to evaluate this function for x equals 1. So they want us to put a 1 in there for x. So just put a 1 in for x on this side, and we'll put a 1 in for x on this side. So we got 1 to the third, 2 times 1 squared plus 10 times 1 minus 15. So all these 1s are, 1 to the third is just 1, so we'll have 5 times 1, so we just have 5 minus 2 plus 10 minus 15. So 5 minus 2, that's 3, plus 10, that's 13. Minus 15, that'll be negative 2. Right? Yes, negative 2. And I like to double check things like that. Like, here's a negative 2. 10 plus 5 is 15. Minus 15, that's 0. And all that's left is negative 2. Just another little check, just to make sure I did it right. Number 12 will be next. And when x equals 5, what is this function worth? Using direct substitution. If you see that word or that term, direct substitution, and you're wondering, this is what direct substitution is. You just put it right in there, do all the computations, and that's it. So when we put a 5 in here, what happens? We get 5 to the third minus 25 times 5 plus 20. 5 to the third, 5 times 5 times 5, that's 125. That's 6 times 125. Minus 25 times 5, well, that's the same as 5 to the third. 25 times 5, so that's minus 125. Plus 20. Here you got 6 times 125. That's going to be 750. Minus 125, 625, and plus 20 is going to be 645. Just check my teacher's edition. Yes, we did that right. And you can do that. Yeah, you should be able to do that without being too confused. You shouldn't be too confused about how I got that. I'm sure you can handle that. Next is 15, and now we're going to start using something called synthetic substitution. And I'll show you what that is. It's really cool. Really cool and really magical. I don't typically like magical things in math, but sometimes I tolerate it. And this is one of those instances. So I'm going to set up synthetic substitution right now. So every time, what you're going to do the same thing. You're going to set up this little L bracket, And what you're going to put inside the L bracket is all the coefficients of this polynomial, making sure that if it starts at starts with a power of 3, that it goes down, each power is represented. This is what I'm trying to say. So we got a power of 3, next should be 2, and next after that should be 1, and it is, and next after that should be just a constant, because 1 would be the smallest power of x that you would have. This really is x to the 0, right? And you'll remember that x, or anything to the 0 is 1, so that's just 16 times 1. Okay, so we put all the coefficients here, since it goes 3, 2, 1, 0 in the powers of x. Next, we put whatever we want to plug into the function, put the 3 that we're going to plug in right there. Okay, and that's going to be the same setup. Actually, there's one more step that's going to be the same. We're always going to bring down this first coefficient outside of the L bracket. Okay, so that's the same every time. You set this up exactly that same way. So the next thing that you do is multiply 3 times 5. Multiply 3 times 5. And then put the result up here. So you multiply 3 times 5, that's 15, put it here, and now you add these two numbers together. 15 plus negative 2 is 13. Now you multiply 3 times 13, that's 39, minus 8, that's 31. 3 times 31 is 93, and 93 plus 16 is going to be 109. Okay, let's just make sure I did that right, yeah. And that number that you stop on, once you have nothing left to do, is it. That's what you should get when you plug 3 into here. You can do it yourself, take 3, plug it in here, cube that, square it there, multiply by negative 8, and so on, add it all up, you'll get 109. So that's synthetic substitution. It's pretty awesome. Let's do another one, just so that you see it one more time at least. Number 20. G of x. 6x to the 5th plus 10x to the 3rd minus 27. Okay, so as we go to set this up, remember what I said. Every power of x needs to be represented. As we go to put the coefficients in here, fill this in, we need every power of x to be represented. So we start at 5, we should see 4 next, but we don't, we see 3. Okay, so how many x to the 4th power do we have? We have 0 of them. Right, we could put 0x to the 4th in there. So now we have 6x to the 5th plus 0x to the 4th, that's good, plus we should see 3 next after 4, we do, there it is. Okay, so we should see 2 next, but we don't, so we need to put an x squared in there. How many x squareds do we have? 0. Alright, so now we're at 2, now we should go down, we should see x to the 1st, which we still don't, so we need another placeholder, a 0x. And now we have down to negative 27, so after x we see a constant. Okay, so now we have all the coefficients we need, we can fill this in. We have 6, next we have 0 from here, next we have 10, then a 0, and another 0, and a negative 27. So you gotta have that. Gotta have those zeros in there. And they tell us they want us to plug in negative 3. So what do? We put negative 3 right there, bring down this 6, and now we start doing the actual math, right? This is just set up. Now we're going to do some multiplication, some adding and stuff. Negative 3 times 6 is negative 18. 0 minus 18 is negative 18. Negative 3 times negative 18. Oh, let's see. That's going to be a positive 44. You might as well pull up the calculator and make sure we're doing this right. 3 times 18 is 54. See what happens. Okay, 54 plus 10 is 64. Negative 3 times 64. Just make sure you get your positive and negative right. So we got negative 3 times 64. That'll be a negative 192. Okay, and 0 minus 192 is negative 192. And 3 times 192 we got negative 3 times negative 192, so that's going to be a positive 576. And 0 plus 576 is 576. And 3 times 576, making sure we have the right sign. Negative 3 times positive 576 is going to be negative, so it's going to be negative 1,728. And negative 1,728 minus 27, so I'm just going to take this positive 1728 and add 27 and just know that it's going to be a negative when I write it down. Negative 1755. There you go. That's what you should get. That's what we have in our answer key, so we're sure we didn't make any mistakes. And that's synthetic substitution. Okay? It's called synthetic because you're not actually doing it directly. You're not plugging it in and finding the result. It's a way to synthesize the answer. 25, I will draw this really poorly for you. Okay, that's kind of like what you see on 25. They want us to talk about the degree and the leading coefficient. Okay. Well, the degree is going to be definitely even. Because for even degrees, we see the arrows, the ends of the graph, the end behavior, going off in the same direction, right? So how did I draw my conclusion? We see the arrows going in the same direction. The end behavior, the ends of the graph on the left and on the right are going in the same direction, so we know even degree. And now, also, they're going in the same direction and they're going up. The ends are going up toward positive numbers. So we know that since they're both up, that we can conclude from that the leading coefficient is positive. That's exactly what they want us to state. Let's look at 26. What can we say about that one? So this one is something like that. So what can we say? We know that we can see that the ends are pointing in different directions. So ends in different directions. So what can we conclude about the degree? The degree is odd then. Since they point off in opposite directions, the degree is odd. Next, we want to talk about the leading coefficient. Since it starts at top left, so it goes from top left to, I'm just going to abbreviate this, bottom right. Top left to bottom right. Starts up here, goes down here. We know the leading coefficient is negative. Okay? So here's the rule of thumb. Actually, I'm going to draw a box around this whole thing here. Alright, so here is a graph that has both ends pointing up. Okay, so both ends going in the same direction, we know that it is an even degree. Even degree. So if they go in the same direction, it's even degree. Well, what if they both go down? How about if both ends go down? Still even degree, but now, in this case, the leading coefficient is positive, but in this case, the leading coefficient is negative. Okay, so we got positive leading coefficient, negative leading coefficient. We got even degree, so we should also have odd degree. So if the degree is odd and the leading coefficient is positive, we'll see the arrows pointing in different directions, and for a positive leading coefficient, it'll start down here. It'll do whatever it does in the middle. We're not worried about the middle, just the ends. It's all about end behavior. leading coefficient is positive, degree is odd, it goes like this. And odd degree, leading coefficient is negative means it'll go something like that. Okay, so that's a little diagram, a 2x2 matrix that lets you know, what's going on there. So we still need that same kind of a, let's actually maybe go back up and use that little chart there. So ignore this little scrawling up here, but pay attention to this as we do number 28. F of x equals 10x to the fourth. That's it, 10x to the fourth. So they want us to fill in these statements. Okay, in the directions, these statements look like this: f of x, and then arrow, meaning like goes to, tends to go toward something. What? We don't know. We're going to fill that in. As x goes to this thing. Okay, let's make sense of that as I write this down here. This other part. As x goes to negative that thing you probably recognize as infinity. As x goes to positive infinity, or on the graph, as x goes to the right. As you go to the right on the graph, or on whatever graph, the graph of this guy. As you go to the right, what does f of x, or y, tend to do? Well, here's the thing. It's a even degree, and a positive leading coefficient. Okay, so even degree, positive leading coefficient, it's going to look something like this. It may not look like the same curve in the middle, but that doesn't matter. Middle's not important. It's the ends that are important. So the ends are going to go off in the same direction, and that same direction is going to be up. So as x goes to the right, as we go to the positive direction and go to the right in the x direction, what does y do? Does it go down here? Does it go down towards the bottom? No. It goes up. It goes towards what infinity? It goes toward positive infinity. Maybe let's fill that in with a different color. It goes toward positive infinity as x goes to the right. As x goes to the left, it goes to negative infinity. What does y do? It goes up as well, so it also goes to positive infinity. Let's do that again. Let's do that with number 29. Alright, we got f of x equals negative x to the sixth plus 4x to the third minus 3x. So we'll use this little chart again to figure out what's going on here. You got it's written in standard form, so this is the highest power right out in front. It's a degree 6, which is an even degree, so it's going to be one of these two, and it's got a negative leading coefficient, so it's going to be here. So let's grab, I'm just going to grab this. Oh, okay, there we go. And we'll erase these two and fill it in. Okay, so as I just said, it's going to be this guy here. So as x goes to positive infinity, as x goes to the right, what does y tend to do, or f of x? It goes down, it goes toward negative infinity. Goes toward the bottom, toward negative infinity. As x goes the other way, as it goes to negative infinity, what does y tend to do? It tends to go also to negative infinity. Okay. Let's do number 31. That'll be the last of that kind. 31 says f of x equals x to the 7th plus 3x to the 4th minus x squared. What's happening with this guy? Let's move this over here. Erase those. Okay. What is this function doing? It's got an odd degree. It is written in standard form. This guy right on front determines the degree. It's an odd degree, so one of these two here, this is the column for odd degree, and its leading coefficient is positive, so it's going to be this guy right here. So as x goes to positive infinity, as x goes to the right, what does y do? Where does it go? It goes up. It goes to positive infinity. As x goes the other way, as x goes to negative infinity, what happens to y? Where's y going? It's going down. As we go to the left on this graph, y is going down. As we go to the right, it's going up, and as we go to the left, it's going down. So it's going to negative infinity. That's what that whole statement is about. As x is doing this, what is y doing? All right. For the last few, we're just going to graph some polynomials. 38. Okay. Well, let's talk about some things that we know. We just got done talking about what the ends are going to do, right? So this is an odd degree, and it's got a positive leading coefficient, so we know it's going to go like this. It's going to be shaped like this. We don't know what the middle is doing quite yet, but we do know the ends are doing that. That's what we'll figure out now, what's going on in the middle. What happens here? We know that in general, it may not go exactly through this particular arrow that I've drawn, but that should be just kind of a double check for us to make sure we're doing this right. So we should get some kind of an idea of what's going on in the middle, so why don't we plot some points near the middle, right? So let's make a table here. Maybe we'll do 0 and -1 and 1, and that should be pretty good. So if we cube 0, put 0 in there and cube it, we'll get 0. Cube -1, that's -1 times -1 times -1. That'll be -1. And this 1 cubed will be 1. So you got 0, 0, 1, 1. Let's make that 1, 1. And -1, -1. So when we go to graph it, looks like it'll do something like this. Alright. If we got our calculator out and we graphed it and had it do it exactly, it would probably look different from this. I can guarantee it look different from this. But we're not interested in making it look exactly right. This is just getting an idea, okay? So, and if you follow these steps, drawing your arrows, right, for the end behavior, so that we can call this step 1, maybe, and then getting a table of values towards the middle, we'll call that step 2, and then actually graphing it, right, that would be step 3, actually connecting all those points. You know, plot 3, 4 points in the middle, connect them, and you're done. Yours could look drastically different, actually. It could look really wrong, actually, but as long as you follow that, that's what I'm interested in seeing you do. So let's look at 44 next. F of x equals negative x to the 4th plus 8x. So let's talk about the end behavior to start again. It's got a even degree right here, and a negative leading coefficient. So we go back up to this thing here, right? And it tells us that the end behavior is going to be both pointing down. Okay. It might be really skinny and not go through those points. It might be wide and not go through those points or those arrows. It might actually go right through them. That's not the point, though. We just want to be reminded that we should see the ends going down. We should make it go that direction. So let's try a few points. You know, like 3 of them. And we may need to plot more. We don't know yet. We'll plot 3 and see how it looks. We'll do 0, -1, and 1. I like those ones. Okay. Put 0 in there. That's a 0. That's a 0. So we get 0. Let's put a -1 in there. So, you know, you can do it in your head or a scratch piece of paper. Maybe I'll make a a scratch piece of paper over here, right? And I've got negative 1 to the 4th plus 8 times negative 1. Negative 1 to the 4th is going to be negative 1 times itself 4 times, which will end up being a positive 1. Then we make it negative, so we get negative 1. Plus 8 times negative 1, that's negative 8, so we got negative 9 here. Alright, so there's negative 9. Let's put a 1 in there. You got negative 1 to the 4th plus 8 times 1, so that'll be a negative 1 plus 8, and so that'll be a positive 7. Right? Let's plot those 3 points, 0, 0, negative 1, negative 9. Let's just make negative 9 here. And then 1, 7. Okay, so here's an example of why I would plot some more points. Because as it looks like it goes like here and then just keeps going up. It almost looks like a straight line at this point. But it's not. It should come back down this way. So I would say plot some more points until you see another point that shows you that it starts to come back the other direction. So let's try a 2. Put a 2 in there. So negative 2 to the 4th plus 8 times 2. 2 to the 4th is going to be 16. So make that negative 16. Plus 8 times 2, that's 16 as well. So this is 0. So there we go. When we plug in 2, now we're back down to 0. So we see it making the shape that it should. We know that it should be going down on the left and down on the right. And so this is a fine graph right here. Okay. If you actually graphed it in the graphing calculator, it may look a little, it may have some more curviness to it than what yours has here, but this is a good job. Oh, that's not at all what I want. Stand by. Okay, got that taken care of. Let's do one more. Which one? 48. F of x equals x to the 4th minus 5x squared plus 6. We're going to graph this guy here. Alright, let's talk about what the ends are doing. It's an even degree. It's got a positive leading coefficient, so if you go back to that little thing up there at the top, you'll see that we know that the ends are both pointing up. Right? So just a reminder as we're doing this, make sure that both ends start going up in the positive direction. Alright, so now let's plot some points. Make a table here. Let's do 0, negative 1, and 1. Those are always good ones to start with. Put a 0 in there, 0, and a 0, and what we have is 6 left over. Alright. Now we got to put negative 1 in there, so let's do that over here. So negative 1 to the 4th minus 5 times negative 1 squared plus 6. That's going to be 1 minus 5 plus 6 equals 4. So we get a 4. No, sorry, 2. There we go. Put a 1 in there now. 1 to the 4th minus 5 times 1 to the 4th plus 6. That's going to be 1 minus 5 plus 6, so also a 2. Alright, let's see what we got going on here. 0, 6. Let's put a point there. Negative 1, 2, so roughly there. And 1, 2, roughly there. So if I had just plotted these 3 points, it would look like this graph should go down, right? But it shouldn't. It should go back up. So let's just plot some more points, one over here and one over here, to make it so that we kind of see what this graph is coming back and looking like. So let's try 2 and negative 2. Let's see what happens there. So let's get rid of this previous scratch and do some new stuff. -2 first. -2 to the 4th minus 5 times -2 squared plus 6. -2 to the 4th, that'll come out to be a positive number. It'll be 16. -2 squared is 4 times -5, so -20 plus 6. So you got 16 minus 20. That's going to be -4. And then plus 6. That's going to be a positive 2. Let's see. Yeah, that certainly could be the case. Now let's put in positive 2. Well, you'll see, it wouldn't take much work to see that when we put a positive 2 in here, since we're raising them to even powers, it's going to come out to be exactly the same thing, so it's also going to be 2. Okay, so let's make some sense of that. They're straight across from each other. But it does show us that, yeah, this is definitely going to have to go through all 3 of these. So it's going to be coming down through those points. But at some point, it's got to come up and go back through these points. Okay, so here's an example of you're never quite sure that you've got it exactly right. Maybe you drew this. You'll get full credit on this. It looks great. I'm impressed. I see your points that you plotted and everything. If you actually graphed it, it may or it may not turn out that the graph should come down and touch the x-axis, or maybe it crosses it. We don't know for sure, but we do know we've plotted a good amount of points. We do see generally what the shape is. That's what we're interested in. And both ends go up, as we know that they should, since we have an even degree and a positive leading coefficient. Okay. That is all. That was a long one. Thanks for hanging in there. Hope that was helpful.